We'll now look at the refraction through a glass plate, through a glass slab, refraction through a glass slab. That means so far we have seen the two different media, how the refraction takes place. Now we'll look at how the refraction takes place when a glass slab is placed along the path of the ray. For example, here is the glass slab I have. This is the glass slab and it has got some thickness. Let us say the thickness of the glass plate is being T. T is the thickness of the glass slab. Now this is the normal I have. This is the normal. Now whenever a light enters from here, it bends towards this because it is moving from rarer to denser. That is the reason it is bending towards the normal. So I is, this is I, this is R. R is less than I. Again, when it comes over here, it is bending into the rarer medium. So this is the rarer medium, this is rarer, this is denser, and again this is rarer. So this is air, I suppose, this is glass, and this is air again. So here one thing you need to remember, this ray and this ray are going to be parallel. These are two parallel rays, of course. That means with what angle it is entering, with the same angle it emerges out. But during the process, it is deviated by some original path. That means if at all the glass slab is not present, it would have travelled along this direction. This is the undeviated path. That means overall it is deviated by a distance of this much. And this is called as, let us say it is falling on A, then this is B, this is C. So here you can think of, it is having a shift. That means the distance between undeviated path and the actual path of emergence is called lateral shift. That means it is entering with the same angle, it is entering, however it is entering, it is emerging out in the same manner. These two are parallel in fact, but it is deviated by some distance. The BC is called as lateral shift here. BC is called as lateral shift. And this is what we need to calculate. BC is called as a lateral shift. And for calculating this, obviously, if this is I and this angle is going to be I minus R. So this is going to be I minus R because this total angle is I. So this R is subtracted. So I minus R is this angle. And here it is perpendicular drawn. This is 90 degrees. Now you can calculate here, this is the distance travelled by the ray inside the glass slab. So AB is defined as, AB is the distance travelled by a ray, inside the slab. So how can you calculate this AB value, you know? If at all I consider this, if I extend, so here it is a perpendicular 90 degrees, then this forms the adjacent side. So from trigonometric knowledge, we have cos R. Cos R is equal to AB by, here I'll just call it as some D, point D, AD by AB. So AD by AB. And I need to calculate AB. Therefore, AB is equal to, AD is coming out to be thickness of the glass plate. Therefore, thickness divided by the AB. AB is required cos R. So this is the formula where you can calculate the distance travelled by the ray inside a glass slab. So this is the distance travelled by the ray inside the glass slab. So this is how you can calculate. Now we require the lateral shift. Lateral shift is BC. Therefore, lateral shift can be calculated as lateral shift can be calculated as, it is totally based upon the geometry and trigonometry. Here I want BC. So from triangle ABC, you can write BC is nothing but, see here, BC is nothing but sine theta. So sine theta BC by AB. BC by AB is equal to sine I minus R. Sine theta here is I minus R. So this is the opposite side by hypotenuse, giving rise to the sine I minus R. And here I want BC I want. So BC is equal to AB sine of I minus R. Therefore, AB value already we got. So T multiplied by sine I minus sine of I minus R divided by cos R. So here, if you know this is called as lateral shift. So BC is the lateral shift here. If you know the incidence angle and refractive angle, or if you know only the incidence angle and the refractive index of the medium, any two parameters, if I R is known, or if I mu is known, or if R mu is known. So if these things are known, lateral shift can be calculated. Lateral shift can be calculated. So these are the two formulae which you need to remember. So this is the expression for lateral shift, and this is the expression for the distance travelled by the light ray inside a medium. That is, here it is a glass plate. And how much time it takes to travel, that also you can calculate. So time taken to calculate. How you can do, sir? Here distance travelled is AB, and in this the velocity of the light is going to be different from the velocity of light in air. Velocity of light in medium you have to take. So similarly, time can be calculated as time taken for the light ray in glass slab. Time taken in glass slab can be written as, that is equal to AB by speed of light in glass slab. Let us say that is Cg. So this is how you can calculate. So these are the formulae which are important in case of glass slab. Here you need to remember one point. When a light is incident, it bends towards the normal. Again, when it goes into the same medium, it bends away from the normal. And by taking the proper geometry, you can calculate all these values. This is how the refraction through a glass slab can be discussed.